Hi, I'm Bobby Gaspar. I'm one of the founders and CEO of Orchard Therapeutics. So let me just tell you a little bit about Orchard and what we do. So we are a hematopoietic stem cell gene therapy company. And the mission of the company, and we've seen this through some of the programs that we've developed, is to end the devastation caused by some very severe genetic diseases. And really to be able to offer potential curative therapies for these conditions. Orchard came about as a result of research that has really spanned decades. I'm an academic physician by training and started working with children, treating children with very severe genetic diseases. Children who really often died from their disease or where the treatments were very limited. But they had a genetic defect in their blood stem cells. And what we and a very small group of scientists from around the world were able to do is to work out a technology to be able to fix their genetic disease. And what we did was to take their blood stem cells, so the child's own blood stem cells, we introduced a working copy of the gene into those blood stem cells, and now those cells had the opportunity to grow a new immune system or to deliver the genes to different parts of the body. And what we were able to see is that we were able to essentially cure some very severe genetic diseases as a result of giving a once-off treatment of modified hematopoietic stem cells. The first child that I treated was back in 2001, and that boy now comes back 20 years later to clinic with a functional immune system. So you can see just how powerful that is. So we were able to take that to that same technology, that hematopoietic stem cell gene therapy, to multiple different diseases. And the success of that led to us spinning out a company that would be dedicated to bringing that therapy to multiple different diseases and many different patients. And so that's how Orchard was formed. And with the work that we've done, we initially concentrated on some rare genetic disorders. So one of the diseases that we were looking at is a rare neurodegenerative condition called MLD. Now, this is a terrible disease. This is a disease where children are born normally, and then they lose the ability to walk, to talk, to interact with their families. And unfortunately, most of those children die in the first decade or so of life. And there is no other treatment available. And what we were able to do is to take cells from these children, correct them, give them back. It's been approved by the EU and it's now available on the NHS. And so that has been immensely rewarding to be able to be part of that journey. But what we understood from that and from other diseases that we've treated is that this technology is incredibly powerful. And having been able to show its effect in some rare diseases, we thought about how could we now take this from rare diseases to more common diseases. If we can correct a rare neurodegenerative condition, maybe this could be used to correct more common forms of neurodegeneration, more common forms of dementia. So that was the ambition that we had, to take the technology from rare diseases to much larger indications. And also, we need, in order to be able to deliver to the much larger indications, we needed to develop the processes, the technologies, the manufacturing to be able to deliver that. And so in order to be able to do that, we had to have our own laboratories. We had to work on these new indications. We had to work on these new processes. And so we looked around very carefully about where we could collaborate with academic partners to have laboratories, to have the infrastructure, the academic and technological infrastructure to be able to collaborate effectively, to be able to develop and work on these programs and processes. So that led us to a very productive and fruitful collaboration with King's Health Partners. They've been incredibly accommodating, and we now have 4 different laboratories on the Guy's campus here, all on in the Guy's Tower. And those laboratories are doing the work on new models, new diseases, such as the form of colitis that I talked about. Though we also have laboratories in association with Catapult, where we're developing the processes and the manufacturing techniques to be able to deliver this to larger indications as well. So incredibly grateful for that relationship. So here we are in one of the Orchard laboratories on the Guy's campus here at KHP. And so And you can see all the machinery, the infrastructures are available. And throughout this biomedical campus, there's a huge amount of technological infrastructure that we're able to use as a part of this relationship. And so we're extremely grateful for that. So the ambition here is to take what we've done for some very rare conditions and take them to diseases that affect many thousands, if not millions of individuals. So conditions such as dementia, for which there is no good effective therapies at present. Forms of colitis and Crohn's disease, which again, where people suffer and there are no curative therapies. What we hope to be able to offer is this technologies, the potential of hematopoietic stem cell gene therapy to be able to deliver once-off treatments that maybe have a profound impact on these very severe diseases. Now, if we can do that, we obviously relieve suffering for individuals and their families, but also it has a huge impact upon healthcare and how we manage healthcare. We don't have curative therapies at present. And so imagine what we can do if we can administer a medicine once and relieve individuals and the healthcare system of the burden of these diseases.